Howdy, my name is Abel Lopez, and my project for senior capstone design was the development and construction of a Stewart platform. The goal of this project was to produce a Stewart platform from a previously constructed but non-functioning model. The litmus test for the functionality of this platform was its ability to be fitted with a touchscreen, in which the system could ultimately, through motorized gyroscopic movement, force a wooden ball, which could be laid anywhere on top of the platform's touchscreen, into the center of the platform. The Stewart platform developed and tested in this project was comprised of four main subsystems. Those subsystems consist of a resistive touchscreen control, the master control unit, or MCU, the proportional integral derivative, or PID, and finally, the electric motor subsystem. The resistive touchscreen control is the first subsystem in this project and is comprised of two main subcomponents. The first subcomponent is the resistive touchscreen, which takes touch input from inanimate or animate object placed on the touchscreen and outputs an I2C signal. The second main subcomponent, also known as the STMP610, in turn receives this I2C signal from the resistive touchscreen and processes the signal into the X and Y values, along with a clock signal which correspond to a coordinate on the resistive touchscreen. Now bear with me folks, these next couple slides are going to be a little rough, but I can assure you it will be all worth it in the end. Now the master control unit, or MCU, is essentially made up of two subcomponents. Well, three if you count the underlying software and library files. These two subcomponents are the Arduino Uno microcontroller and the Adafruit motor shields for Arduino. The Arduino Uno microcontroller is responsible for serving as the hub information exchange between all of the other subsystems, and in collaboration with the loaded software, is ultimately responsible for commanding the motor shields to drive the desired motors to displace the platform. This subsystem was not much of an issue. The motor shields had to be replaced once. Ultimately, this subsystem performed as required. Now, to accomplish the system requirement of forcing a small wooden ball to be placed anywhere on the top of the Stewart platform, so as long as it made contact with the touchscreen, a PID feedback system was utilized. Now, PID stands for proportional integral derivative, and essentially this module received the X, Y, and clock value inputs from the STMP610 and compared those inputted X and Y values against a predetermined set of X and Y values, and outputted the difference between these two set of values into the master control unit. As you may have guessed, these predetermined set of positional values stored inside the PID module, or coordinates, were in fact the values which correspond to the center of the platform. This module was completely software-based and from an Arduino library file. Appropriately so, this subsystem compiled and integrated into the final integration quite smoothly. The motors that were utilized were a total of 6 unipolar, 2-phase, 6-wire stepper motors, wired under a set of 4 wires. As you can see from the video, these motors function quite properly and were probably the only subsystem which required no replacement of parts. What you are watching in the video is in fact one of the first tests of the fully integrated system properly functioning. This is the fully integrated system operating at its peak during these last few weeks. As you can see, this complete system integrates all 4 of the previously mentioned subsystems. The resistive touchscreen control, which sends coordinates into the master control unit, which in turn sends and receives feedback from the PID subsystem on how close the previously inputted touch input is to the center of coordinate of the touchscreen. And through a limiting method of trial and error, the the master controller unit performs its function of picking a set of motors out of 6, which can alter the platform's 6 degrees of movement into balancing the wooden ball into the center of the touchscreen. In conclusion, the system requirement of developing a Stewart platform from a previously constructed model, which did not seem to function properly, was accomplished. Some improvements I foresee that could be made to the project are a complete overhaul of the resistive touchscreen control subsystem. Time and time again, this subsystem did prove to be very unstable as the touchscreen was prone to being damaged through fracturing, and the STMP610 touchscreen controller was difficult to troubleshoot. I'd like to thank Dr. Villarreal for the assistance and the opportunity to work on this project. Thank you for your time.